Hey everybody. So last week of content. Hang in there, we are almost done. Right now we're going to start talking about stuff from section 7.4, and then we're also going to be covering a little bit from another section today as well, and I'll let you know when we get there. When you start doing the homework, what we're about to do is section 7.4. So we've been talking about probability and counting and all that, and we're going to continue talking about probability in this video. And we're going to introduce a rule. It's the addition rule. The probability of an event A or event B happening is the probability of A or B, or we could also write that with, set notation. We could write the union symbol, same thing. So the probability of A or B is equal to the probability of A occurring plus the probability of B occurring minus the probability of those two events occurring together, or the probability of A and B. Remember, this is the intersection symbol, which means and. So anytime we want to figure out the probability of something happening or another thing happening, so that doesn't mean they both have to happen at the same time. It could be one or the other. This is the formula that we'll follow. We add the probability of each individual thing, but we have to take away the probability of those two events happening together at the same time. And then that will give us the probability of either event happening. Okay, so let's just look at some examples. Number one, a bag of 11 marbles contains 5 marbles with red on them, 3 with green on them, 7 with black on them, and 4 with black and red on them. So it sounds like these are multicolored marbles. They each have different colors on them. So there's some overlap here. So, like this last little bit, 4 of them have both black and red on them. So the question is, what is the probability of randomly choosing a marble with black or red on it? Or. So once again, we're trying to figure out what's the likelihood of us pulling out a marble that has either just black, just red, or it could even have both. So how we would write this out, the probability of black, I'm going to put the union symbol, or red, is going to be equal to the probability of choosing a marble with black on it plus the probability of choosing a marble with red on it minus the probability of choosing all the marbles that have, or a marble that has both of those colors on it. We have to subtract that because essentially we don't want to double count. We've accounted for all the black marbles in this first probability. Here we're counting for all the marbles with red on them, but we might be double counting marbles. The marbles that have both black and red on them. So that's why we subtract this piece right here. All right, so the probability a marble will have black on it. So if you just go back and read, it says here in the problem there were 7 marbles with black on them. So, and there was 11 total marbles, right? So the probability of choosing a marble with black on it is just 7 out of 11 marbles. Plus, how many of the marbles had red? There were 5 marbles with red on them. So 5 out of 11. Now, once again, this accounted for all the marbles with black on them. This accounts for all the marbles with the red on them. But we could be double counting the marbles that have both black and red, so we have to subtract that. And if we read the sentence again, there were 4 marbles with both of those colors, black and red. So we're going to subtract 4 out of 11. So now we just simplify. Common denominator here. So when we're adding and subtracting fractions, you leave the denominator the same. And then we can just add and subtract across the top. So 7 plus 5 is 12, minus 4 will bring us to 8. And that's our answer. The probability of choosing a marble that has either black or red on it is 8 out of 11. Now, once again, that means we could pull out a marble with only black, a marble with only red, or a marble that has both colors. Okay, so let's try another one. But here we kind of have a table. Suppose a student is chosen at random to receive a gift card for filling out a survey. The following table shows, should be tables, shows a breakdown of who filled out the survey. So here we go. What is the probability that the winner was either a freshman or a member of the student government? So we want to figure out the probability that the student was a freshman or union, a member of student government. I'm going to put G for government. F for freshman, G for government. Cool. So we're just going to use this same formula. It's going to be the probability of choosing a freshman plus the probability of choosing somebody in the student government, and then you want to take away the probability of those things happening together, someone being a freshman and a member of the student government, so we're not double counting. Okay, so the probability of picking a freshman, what's nice about this chart is that they have totals here, a total row, and they have a total column here at the end. So we know if we look here at this freshman row, there's a total of 18 freshmen. And also, if you look at this very bottom corner, 46, this is the total number of people that they're talking about in this table. Just note that in Hawks, not all the tables might give you these totals, so you might have to sometimes add these numbers together. But you'll notice here with the 18, that means there's 3 freshmen in this first column, there's 15 freshmen in the second column, 15 plus 3 is 18. So just know that you might have to do some of the addition with tables like this by yourself in Hawks. Okay, so the probability of choosing a freshman. So there were a total of 18 freshmen out of all 46 people. So that's my probability of choosing a freshman, 18 out of 46. Plus the probability of choosing somebody that is in the student government. So see this column, student government member, and this lists all the people in the student government broken down by their class. But down here you can see there's 10 people total in the student government out of all 46. Now we want to take away the intersection of those two, what's in common, so we're not double counting. And basically we're going to look at the intersection of that column and row, freshman and student government, and there's 3 people that are both a freshman and a student government member, so 3 out of 46. And just like the last problem, with addition and subtraction of fractions, you keep the bottom the same, and we just go across the top, and you should get 25. And when you guys do Hawks, you can leave it as a simplified fraction, which 8 over 11 up here, this is as simplified as that can get. 25 over 46, that's also simplified, but you can also type it into the millionth place, which is 5 decimal places, and just make sure you round properly at the 5th decimal place. So I got 0.54348, but you could put either of these answers in to Hawks. Okay,